Hi, my name is Monica Lewis. I'm a grad student at the University of Michigan going on the job market this semester. My advisor is Mel Hochster, and my research is in commutative algebra. I'm going to give you a quick overview on the kinds of things that I work on. So, broadly speaking, I'm interested in finiteness questions about local cohomology modules, especially in the characteristic P case. Now, to give you a bit of background on that, local cohomology is a tool introduced by Grothendieck that has since proven to be widely applicable throughout commutative algebra and algebraic geometry. But they can be very difficult to control because they're rarely finitely generated. Now, that doesn't mean that the situation is always bad. In fact, the situation tends to improve quite a bit when you're working over a regular ring. So, when the underlying space is smooth, you gain access to powerful tools that you wouldn't have had otherwise. For example, in certain equal characteristic zero settings, you gain access to a nice ring of differential operators. In characteristic P, you gain access to a particularly nice action of the Frobenius. And this has a number of powerful consequences. For example, the local cohomology of many regular rings is known to always have a finite set of associated primes. This indicates how nice the setting is when you're working over a regular ring. This is a very nice property, but much less is known when this base ring that you're working over is singular. In fact, it's known that the finiteness property for associated primes can fail, even when you're working over a hypersurface. So, you may be willing to forget about this scheme-theoretic fuzziness of the full set of associated points and settle for the set-theoretic question of when do these modules vanish and when do they not. And a question that I'm particularly interested in, along these lines, is does the local cohomology of a complete intersection ring always have Zariski closed support? So we know that it can have an infinite set of associated primes, but might it always have a finite set of minimal associated primes? The question turns out to be yes for hypersurfaces of positive characteristic. This is due to independent work of either Hochster and Nunez-Betancourt or of Katzmann and Zhang in 2017. So it remains wide open for complete intersections of higher codimension. Much of my work is focused on the question of how might what we know about hypersurfaces generalize to the higher codimension complete intersection setting. And I've worked on a number of projects in this area, so let me give you an overview of some of those. I've done quite a bit of work on the local cohomology of a parameter ideal, and you might ask what that has to do with the closed support problem that we just discussed. Well, given a regular ring R and a parameter ideal J inside of it, along with an ideal I containing J, we might try to compare the local cohomology of J to the local cohomology of the complete intersection it cuts out in 1 degree lower. In fact, this was a key ingredient to Hochster and Nunez-Betancourt's hypersurface result. However, I've given some comparison theorems on the sets of associated primes that indicate major difficulties with generalizing this strategy to higher codimension. In fact, I've given an example in which the module HIIJ can have an infinite set of associated primes, and we'll talk about some implications of that later. I've also, while not directly applicable to closed support, given some positive results in the case of regular parameter ideals, at least in characteristic P. So, more recently, I've done some joint work with Eric Canton, in which we've constructed a simplicial complex with a compatible Frobenius action that generalizes a more familiar complex, recognizing the hypersurface R mod F as the kernel of multiplication by F on the local cohomology module, H1 with respect to F of a regular ring R. Now, given that this complex can be used to obtain the Hochster-Nunez-Betancourt result by a slightly different argument, one might hope that a generalization of this could lead to alternative avenues for attacking the closed support problem, and that is indeed our hope, that this might provide a possible alternative route of attack on higher codimension problems. We have some positive results indicating closed support under certain vanishing hypotheses and in certain cohomological degrees that I'm excited to talk about. But much remains unknown. We're far from the general case, and there are a number of wide-open questions about finite generation on this complex, at least finite generation after augmenting a Frobenius operator to R, that can imply some very interesting things. So I look forward to talking at some more length about all of these problems that I've been discussing here, and to showing you some of the cool things that I've been working on. So look forward to seeing all of you guys at my talk. Bye.